Okay, I've been updating lessons and doing videos and teaching classes remotely all day. My head is kind of spinning. It is now 3:25 on a Friday, and I would love to get one more video completed before I call it a day. So let's give this a shot. This is 5.6, the laws of logarithms. And on your homework for 5.5, there were a couple problems where they wanted you to start using some of the laws of logarithms that you used last year. So I introduced them all to you just as a tool, and I'm curious how you did. Today's objective is to prove and apply the laws of logarithms. So we want to walk out of here today having these laws down. Okay? So here they are right here. First, let's put them on paper. The laws of logarithms. These are so simple, yet so critical. So let's begin to memorize them. If m and n are positive real numbers, and again, positive real because of our domain of a logarithm, and b is a positive number other than 1, then, here's your first rule right here. Number 1, the log base b of m times n. Now, whenever I see a log of any base of the product of two terms right here, I should say a product, I know I can write this one log base b as the sum of two of them. So I'm going to go plus, and then I have the log base b of m plus the log base b of n. Okay, so sometimes we have to go from the right to the left to simplify, and sometimes we're going to have to go from the left to the right. We're trying to give you tools so you can do most of these problems right in your head. Now, number 2. Now this time I have the division right here, the log base b of m divided by n. And that's going to give me the difference of two log base b's. And that would be the log base b of m minus the log base b of n. Rule number 3. The log base b of m equals the log base b of n if and only if, well, I have the same log base b on both sides. That can only be a true statement if m equals n. And then finally, this is the one we used right at the end of our last lesson when we were solving these logarithmic equations. The log base b of m to the k power. Anytime I have an exponent here, as long as this k is in the set of real numbers, or if k is a variable that can be any real number, I can bring that exponent out front as a coefficient. So the log base b of m to the k equals k times the log base b of m. And again, in all of these rules right here, all of these laws of logarithms, to be able to do this in your head, you might be going left to right, or you might be going from the right to the left. Awesome. Okay, and add the laws of exponents to this, and you've got almost everything you need to go to the college and into advanced mathematics. So this is all so big. All right, so here's our first example, and you're going to see test questions that look just like this. Express the log base b of m times n squared in terms of the log base b of m and the log base b of n. So they're asking you to take this expression and use the laws of logarithms to rewrite it. Okay, and there they are. So my first thought is m times n squared. I'm going to write this one log base b as the sum of two log base b's. So there's my plus, and my first term is going to be the log base b of my first factor m. And then my second term is going to be the log base b of my n to the second power. And I usually skip this step because I only have one more thing I need to do, and that's rewrite this right-hand side right here. So I have the log base b of m plus, and what can I do with this exponent? Well, here it is, number 4. It can come out front as an exponent, as a coefficient, excuse me. So I'm going to write the log base b of n squared as 2 times the log base b of n. There it is right there. And now we've written the log base b of m times n squared in terms of only the log base b of m and the log base b of n. Awesome. Well, let's do another one. Now first, I need to remember my rule for square roots. I can write any root as a rational exponent. So I'm going to do that so that I can apply my laws of logarithms again. So a square root is the same thing as an exponent of 1/2. And now what do I have? I have a 1/2 as an exponent. That can come out front as a coefficient. Just like that. And now, do you see the division? That's right, we're using number 2. I can write this log base b of m to the 3rd divided by n as the difference of 2 log base b's. So let's set this up with 1/2 and a difference, and this first term right here is going to be the log base b of m to the 3rd minus the log base b of the n. And now that 3 can come out front. So we have 1/2 and we have the log base b of m, but see that exponent of 3, let's bring it out as a coefficient of 3. 3 times the log base b of m minus the log base b of n. And we've done the second problem now too. We've written the log base b of the square root of m to the 3rd over n as 1/2 quantity 3 times the log base b of m minus the log base b of n. Okay, now again, what are these all about? It gives us the ability to simplify logarithmic expressions in our head without a calculator. Anybody could punch that out on a calculator right now. In fact, I'm going to do that right now. You know? And again, this is not about you just using a calculator. It's about, do you know your laws of logarithms so you can do this without a calculator? But let's find out, what is the common log of 45 minus 2 times the common log of 3? And my calculator is telling me I'm getting 0.698970043. Oh my. Now, is there a way that we can simplify this and to get a prettier answer than that decimal 0.698970043? Well, let's find out. Laws of logarithms. Do you see I have the difference of 2 common logs? Well, the log base b of m minus the log base b of n equals the log base b of m over n. So let's write this as 1 common log. And before I do that, oh, do you see this coefficient of 2? Let's bring that as an exponent. So that becomes the common log of 3 squared, or the common log of 9. Now, let's go ahead and write this as 1 common log. So that's going to be the common log of, and I have 45 divided by the 9. And now, one more step. What is the common log of 45 divided by 9? Well, what's 45 divided by 9? 9 goes into 45 5 times. So that's the common log of 5. Now, when I punch that out on my calculator, what did I get? 0.698970043. I'll bet you if I now punch out the common log of 5, I get the same thing. Common log of 5 is, and guess what? 0.698970043. So we have now simplified the common log of 45 minus 2 times the common log of 3, and we got the common log of 5. I'd say this is way prettier than the original. All right. Express y in terms of x if the natural log of y equals 1/3 the natural log of x plus the natural log of 4. Now I need to write this as y equals something in terms of x. And I better use my laws of logarithms. So I suggest to start, we're going to simplify the right-hand side. So the natural log of y equals, well, this coefficient, can't that become, instead of 1/3 the natural log of x, could I write that as the natural log of x to the 1/3 power? Oh, look at that. Plus the natural log of 4. So there's my step 1. Now, if I can write this right-hand side as 1 natural log instead of the sum of 2 natural logs, I can finish this problem. So what's my rule right here? When I have addition of 2 natural logs, well, look it up here. The log base b of m plus the log base b of n equals the log base b of m times n. So this should be the natural log of x to the 1/3 times 4, which how about I write that as 4x to the 1/3. And now, I have the natural log of y equals the natural log of 4x to the 1/3. All right, well, look at number 3. The log base b of m equals the log base b of n if and only if m equals n. So this tells me that this statement can only be true if y equals 4x to the 1/3. So we are done with that problem. Oh, this is fun. Okay, solve. So what have we been doing? Simplifying and taking a logarithmic equation and expressing it as y in terms of x. Now we're going to solve some complicated logarithmic equations. And to do that, we use our laws of logarithms to simplify. Okay, so let's try to rewrite the left-hand side. I have the sum of 2 log base 2's right here, and we're going to write that as 1 log base 2 using rule number 1. So that's going to become the log base 2 of, and then what do? I multiply x times the quantity x minus 2. Okay, and what's that equal? 3. There's step 1. Now step 2, the log base 2 of x times the quantity x minus 2 equals 3. How about we go definition of log right now? Oh yeah, here it is. Because that's going to be my base 2 to the 3rd power has to equal the product of x times x minus 2, which I might as well write that as x times x squared, and then x times negative 2 minus 2x. And now I have a quadratic equation. So we went from a logarithmic equation to a quadratic equation by simply simplifying using the laws of logs. So let's solve our quadratic. Well, we better get everything on one side. Let's put this in quadratic form. So 0 equals x squared minus 2x minus that 8. I bet that's factorable. So x times x will give me the x squared. And then I need two numbers whose product is negative 8 and whose sum is negative 2. Wouldn't that be a negative 4 and a positive 2? And by the zero product property of algebra, if x minus 4 times x plus 2 equals 0, then one of those factors would have to be 0. So that tells me x can either equal 4 or negative 2. Now, be careful right here, because if we were solving the quadratic equation, there would be our two answers. X is negative 2 or 4. But what did we begin with? A logarithmic equation. And isn't the domain of any log function the positive real numbers? Remember, that graph of a logarithmic function looks like this. We're never over here in quadrant 2 or quadrant 3, so the domain is only the positive real numbers. X has to be greater than 0. So if you give me x can be -2, that's not going to work right there. All right, because if I did the log base 2 of -2, try to punch that out on your calculator. You can't do that yet until I give you the change of base theorem, and I don't think I've done that yet. So we can't punch it out quite yet, but trust me, all right? The log base 2 of -2 does not exist. So my only answer that is valid right here is x equals 4. Man, I hope you're enjoying this as much as I am. So today I'd like you to do 5.6, 1 through 49, every other odd, and then number 51. You guys have a great day, and get a hold of me if you need some more help on anything.